Hello everyone. Today I am going to walk you through MVI architecture. So, so what exactly is MVI architecture? So, in MVI architecture, all the UI state is consolidated in a single state object. All the UI state is consolidated in a single state object. So, uh, and 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 the UIs and the UI uh, and the UIs observe the state and render the screen accordingly. So uh, every action performed by user on the screen, it is called as intent, and view model receives these intent and executes business logic and produces a new state object, and then the UI observe the state and re-render the screen accordingly. So this is the main idea behind the MVI architecture. There are various ways to achieve this, and we will build it step by step and gradually increase and gradually increasing the complexity. So suppose there is a screen, we called it as QR scan, and this UI screen state depend on two things: color and the progress. So what we can do here is simply uh, let's create the UI state that holds the current state. So what we can do here is expose we can expose a simple update function like set color to update the state. Similarly, we can expose and we can expose an update function to update the progress. So uh, all these state change are comes from the user actions. uh, this works fine when the state change come when the state change comes from the user action. But what if the state changes what if the state gets changed from the repository or the local DB sources? Then no. uh, what we can do here is what we will do here if uh, what we will do here the repo if the if the states gets changed uh, from the repository. So there is a method called get color, and it returns the flow of color. So what we will simply we will simply update we will simply collect uh, the value we will simply collect the streams of color and update and update the color. Similarly, we can do this for progress. So this works fine, but as the app grows or the app complexity increases, uh, uh, as the app grows or as the complexity increases, the mutation sources, like the get color or get progress, all these mutation sources start spreading across the view model, start spreading across the view model, and it becomes very difficult to track, uh, it, very difficult to track what is mutating the state and from where it is mutating. So there is a better way to handle this, and what we can do is we can centralize all the mutating sources in a single place. uh, we and we can centralize all the mutating sources in a single place and create a single flow of streams that uh, reduced the mutations into the state object. So how can we do this? We can centralize it and keep all the mutations in a single place by using the merge operator. So what we can do here is we will put all our mutation sources inside this merge operator. So what is mutation? Mutation is basically mutation takes the current state object and returns the updated state. So we'll define mutations as uh, we'll define the mutations as this lambda. That QR view state is a receiver to this lambda, and it will return the updated QR view state. So what we will do here is we will uh, get the color mutations from from the repository data sources. Instead of collecting, you can map the latest object if you want the latest values only, and we will emit uh, the flow of mutation, and we will return the flow of mutations. And we can put this get color mutation. Similarly, we will get the progress mutation, and it will also return the flow of mutation. And we will also add this progress mutation here. Now when when this progress mutation or this color mutation emits any value, we need to reduce this into it will require the initial object, so private val seed so let's define this reduced it into function that reduced the flow of mutation into the state flow. Private function reduced into that will be called from the extension function flow of mutation, and it will accept initial state. Scan is basically it works like it basically scans it works like the running for, but for each intermediate value it will emit all the intermediate values in using the scan. So it will take the initial object and state comma mutation, and it will returns the updated state. Then it will return the state flow, and then on each we will update the seed, and we need to convert the state flow into the hot flow, so we can use state in operator here. Now we can put all these mutations here in the merge, and by and we can track all the mutations easily here. But what if we also want to support the mutations from the user actions? For that, suppose we exposed a function like set color and we want to update the state here. We don't need this, so how can we do this? For this we will exposed for this we will define a shared flow for the user action. We call it change event. And we will also add this will take the mutations. All these types are the flow of type mutations, so this should also all these three should be of the same type. Okay, so what set color, what it will basically do is the model scope dot launch underscore change event dot emit copy dot color. So what will it will emit this mutation, and when this emits a mutation, reduced it methods gets called, and the reduced it will update. It will call this mutation lambda, and this lambda will gets called. And this lambda gets called and update the color, and we will update the UI state. So that's how we can create a simple state function to centralized all the mutations at a single place.